Let us go to the next question, 3.3. I think that should have been a lesson for you. 3.3, skets die posisie tydgrafiek vir die projektiel X en hulle gee vir 'n periode vir jou vir die periode T 0 sekondes tot T 6 sekondes. Neem die rand van die krans as die nulposisie. Ek lees weer, neem die rand van die krans as die nulposisie. Kom ons kyk hom gou lekker in Engels, net om te onderstreep. Sketch the position time graph for projectile X for the period T0 to T is equal to 6 seconds, from 0 to 6 seconds. And now in capital letters, use the edge of the cliff as a 0 position. Okay, now let me get back to my graph here. Right in front of me. This, in fact, is my position time graph because it tells me exactly where the projectile is every step of the way. But now the examiner gives me a clear instruction. He says, use the edge of the cliff as your 0 position. Which means, if that is 0, and my x-axis is going in this direction, and my y-axis in that direction, and on top of it, if it was 3 seconds up till here, and I know from my physics classroom that if it takes 3 seconds to get to the maximum height, it will also take 3 seconds to get back to the same position as where it started from. Het jy het? As dit 3 sekondes geneem het om op te gaan, dan gaan ook 3 sekondes neem om af te kom. Tot by dieselfde punt. Nie tot onder nie, tot by dieselfde punt, selfde hoogte as van waar dit afgevuur was. I think you got that, huh? So it's 3 up, so that's 3. This is 0 seconds. That's 1, 2, 3, 4, 5, 6 seconds. And I can redraw that graph very quickly on the side. So I'll just do it here on the side, 3.3. I will then do the following. I'll draw my axis, x-axis and the a-axis. And of course, I can tell the examiner what kind of graph this is. This is my position. And my position normally is in meters. And my time graph, which is normally in seconds. Kom ons kyk maar die Afrikaanse een ook hier so. En dan hier is die posisie. En dan kopieer ek net daar die grafiek soos hy daar lê. En ek gaan op en ek dui hom so aan. Bring hom net so en ek weet nou ek moet die volgende aandui 3 sekondes by die hoogste punt, 0 sekondes aan die begin en dan kan ek 1 en 2 insit en ek kan 4, 5 en 6 aandui. En ek dink dis wat die examinator wou gehad het. Hy wou aangegee dat jy moet aandui die hoogste en dan ook die tyd dat het by die krans weer aankom, by dieselfde posisie. So jou grafiek so lyk, daar is ook ander maniere om te teken, maar dit sou die basisse een vir daardie wees. Right, let me just emphasize a few things for you about this, the drawing of the graph. Make sure that you have your y-axis and your x-axis and that you indicate or give a label to the y-axis and the x-axis. In my geval, posisie, waar is hy? Hoeveel meter van die beginpunt af? In meters. So your position, please indicate your units in brackets like I did in this case with meters. And then when you get to the time x-axis, then you also indicate your units, and in this case it would have been in seconds because we work with the International System of Units, which for physics is in seconds. In this case, time is in seconds. Do you think you've learned something from it? Okay, the next question I'm going to ask you to read carefully a few times, and then we can, for that matter, ask you to attempt something in this question. Let's see, it's question 3.4. 1 second after projectile X is fired, the man's friend fires a second projectile Y upwards at a velocity of 49 meters per second from the ground below the cliff, and again it is in capital letters. The first projectile X passes projectile Y 5,23 seconds after projectile X is fired. Oh, it's a lot of information. Let's read it in Afrikaans quickly, and then I'll do a write-up in a way which I think could help us to discern exactly what is happening here. Kom ons lees hom stadig. 1 sekonde nadat projectile X afgevuur is, vuur die man se vriend 'n tweede projectiel Y opwaarts teen 'n snelheid van 49 meter per sekonde. En hier gaan alweer hoofletters wat beteken baie belangrik, vanaf die grond onder die krans. Die eerste projectiel X gaan projectiel Y verby 5,23 secondes nadat projectiel X afgevuur is. I think we need to do something here again. Let's go. We need to read this question very, very carefully. It's so important that you keep your focus, that you look at the question quite a number of times, that you extract information from the question, and that you actually put it down for yourself so that you have some idea about what is happening, so that when you do your calculation it becomes very easy. What I'm going to do, I'm going to extract all the information regarding projectile X and projectile Y on the sheet in front of me to clarify in my mind, and for myself I'm even going to draw a little sketch so that I can be sure I understand the situation. Het jy hom? Projectiel X en projectiel Y word op verskillende tye afgeskiet en hulle gaan van verskillende punte af nog boonop, en ek moet nou so waar my koppel. En ek gaan 'n metode voorstel waarop ons op hierdie vraag kan benader. Dit om seker te maak dat ons geen feite langs die pad verloor nie. Let's see. I'm going to, on the whiteboard, I'm going to look at my question paper at the same time, but then I'm also going to try and analyze what the situation is. Right, here we go. I'm going to draw a little block and say I have projectile X and then projectile Y. I think that is the best way of dealing with this situation. First of all, the initial velocity of this one, I remember, was 29,4. I think the initial velocity, if I look at my question paper, and I want you to do so too, the initial velocity of projectile Y is 49 meters per second. So the initial velocity here of this one is 49 meters per second. And what else do I know? The one, and I'm going to make a little drawing here to the side for myself once again, and I think the one projectile, if this was the cliff, went up and was on its way down. And then another projectile, if this was x, the movement of x, and then another projectile was shot up before it reached this point, because I think it was the time there was after, if I look at my screen again, it was after 5,23 seconds. 5,23 seconds, which means that if I go back here, it wasn't at this point yet, it was somewhere there. So at some stage, this one, while it was there, projectile y was fired up. So this is projectile y, that is x, just make it slightly bigger. And I think that is the only information I have. No, there's another piece of information. It says that projectile y was shot 1 second after projectile x was fired. Okay, I have it now. Kom ons lees dit weer 'n keer. Die 1 sekonde nadat projectile x afgevuur is, vuur die man se vriend 'n 2 projectile teen 'n snelheid x in. That means that the time, if I can go back to my whiteboard, that means that the time for projectile y was 5,2 minus 1 second, because it was 1 second later that it was fired off. Okay, there we have some idea of what's going on. Let's get to the question now and see what we can make of the question. The question is, jy moet bepaal die snelheid van projectile x op die oomblik wanneer dit by projectile A verbygaan. Jy moet die snelheid bepaal. Nou as ek teruggaan na my bord, voor my witbord, dan sien ek dat dit het opbeweeg en begin met 29,4. Hy het opgegaan waar die snelheid 0 was en toe het hy weer af begin beweeg. En 'n interessante ding wat 'n mens altyd kan onthou, dat as hy hier kom, gaan die snelheid weer 29,4 wees. Maar dit is nie daardie punt waarvan ons praat nie. We refer to an earlier point which was at 5,23 seconds. Okay, so I now again have to use my data sheet. I get that in front of me because this is my most important piece of equipment I have in the examination. And I sit here and I think, what do I have? I have initial velocity 29. I have the time. What else do I have? I should have always have 3 things, because all of these tables, all of these equations contain 4 unknowns. So I should always have 3 and calculate 1 unknown. What must I calculate? Oh yes, I should calculate another final velocity. That is the velocity. Ek dink dis die vraag, die snelheid van projectiel x, ja. So ek werk met projectiel x, ek moet die snelheid bepaal. Something is missing. Aha, you never ever should you forget that you have to include gravity, because that is a known factor. So let's quickly see how we tackle this one. Let me see. So how do I go about this? I need something with initial velocity in it, with time in it, with final velocity in it, and g, or sometimes as we call it a. Okay, so I look through it and hey, this one seems to be good enough. If you can just look at it very carefully, you'll notice that this one has got a final velocity in it. It's got an initial velocity in it. It's got the acceleration in it, and it's got time. So this is the one I'm going to use. Okay, the others won't help me much, but for now, this one will work. So let's go and do this one. I'll write it down then. The formula that I have to use here to calculate that question is the final velocity, that's the one I must calculate, is equal to the initial velocity plus a, and I think it is delta t. There we go, the change in time. I have to copy the equation exactly as is on the datasheet. Het julle hom? Julle gesien hoe kry ek hom? Ek kyk na wat ek het en dan neem ek die korrekte vergelijking daarvoor. Goed, die beginsnelheid was 29,4 plus, o ja, wat ek vergeet. Omdat ek nou in hierdie rigting werk en ek het al reeds 29,4 geskryf, maar dit was toe hy opgegaan het, dit wil sê ek gebruik opwaarts as positief. Ek gebruik upwards as positief. So I use upwards as positive. And I use downwards as negative. En daarom is hier die plus 29, dit wil sê ek het opwaarts as positief geneem. En A, my zwaartekrag, is altyd afwaarts, so dis negatief. En ek maal dit met die tyd wat het geneem het, dit wil sê 5,23. Maar ek doodseker jy verstaan hoe ek dit gekry het. Ek wil dit bepaal. Hierdie weet ek uit die gegevens wat gegee is. En dis opwaarts, daarom is dit positief. En plus, daar is die plus weer. En A of G is gravitasie, wat 9,8 is. Maar dis afwaarts, daarom die negatieve teken. 9,8 maal 5,32, die tyd wat hulle vir my gegee het. Goed, kan jy dink, ek gee 'n minuut of 2 om dit uit te werk en sien of jy vir my die antwoord kan kry. Goed, kom ons sit nou hier getalle in en sien of ons die regte antwoord kan kry. 29,4 en hier natuurlik minus en dan sit ek die res in hakies 9,8 maal met 5,23. 5,23 maak my hakie toe en ek kyk wat is my antwoord. Die antwoord is minus 21,85. Dit is nou meters per sekonde. Dan maak ek 'n sinnetjie omdat die negatief my aandui, dit is afwaarts, want opwaarts is positief, so dit is afwaarts, so ek kan sê, hier projectiel was op pad af en dan my antwoord is korrek, so dit is die snelheid van die projectiel, op daardie tydstip was 21,85 meters per sekonde afwaarts. You got it. So the velocity was 21,85 meters in a downward direction. Please write this down so the examiner can see it clearly. Right, ons het nog 'n paar minute oor. Kom ons kyk na die laaste een gou-gou. En ons wil weet, wat is die snelheid van projectiel X relatief tot projectiel Y op die oomblik wanneer die projectiel Y verbygaan? O, ek sien, lees weer, die snelheid relatief tot projectiel Y. Let me see what the English version says. The velocity of projectile X relative to projectile Y. So it's a relative velocity I have to work out, which means I should have two velocities. All right, let's do the second part of it, which means I should have the velocity of X, which I've just worked out, and then I should have the velocity of Y, and then I should have the relative velocity between the two. So let's get down then to the velocity of y. Let's, on the whiteboard, look at what we have so far. So far, just to remind you, we have velocity of that is 49 and the time is 5,23 minus 1. So I will just rewrite everything down here again. For y, I now know that for x, the velocity that I've just calculated was 21,85 meters per second, and now I must calculate for y. What do I have? The velocity of, initial velocity of y was 49, and the time is 5,23 minus 1, which is 4,23 seconds. So that's the one that I have. So what do I need? I now need the final velocity of projectile y. Again, g is 9,8. If I take upwards as positive, then surely I do have the following. I can use the same formula again. That one is the initial velocity plus a and the change in time, and therefore I will have 49, right? 49 was its initial velocity, plus g, which again is negative 9,8, and the time this time is 4,23. Use your calculator and let's see how quickly we can get this answer. Right, here we go. So it's 49 minus, put the brackets down, 9.8 multiplied by 4.23. 4.23, and I think I should get an answer as 7,55. So the answer is 7.55 meters per second. Now I have two velocities. Let me quickly underline them in red for you. I have the one 7,55, and this is y, and I have x as 20, and x is 21,85 meters per second. Okay, so I have two velocities. So how do I determine the relative velocity of x to y? This is the following that I think by now you should know. Whenever you have the one projectile is coming down, this one was coming down, and this one was shot upwards, whenever I have two velocities in the opposite direction, I normally say a simple rule, add the two velocities as follows. So I will write the velocity of projectile x with regard to projectile y compared to projectile y, or relative to projectile y, is equal to the velocity of x relative to the ground added to the velocity of the ground relative to y. That's the way I write it. This is something that you can learn and always remember. And so what do I do now? Then I write down the two velocities. Remember, the original velocity was downward, because I'm working now from x to the ground, which was downwards, which means that it was minus 21,85. Remember, downwards was negative, and this is x to the ground downwards, plus, and this one, y to the ground was 7,55 from y, but now because it's upwards and I change it around, I now get negative 7,55. And then, of course, if I add these two together, I should get, let me see, 29,40 meters per second.